Solve for x in this equation. 4 times in the parentheses 2x minus 5, close that parenthesis now folks, that's important, equals 2 times, another parenthesis coming up, 4x minus 10 with a closed parenthesis on the other side. So we're going to play some distributive property. Again, solve for x in this equation, 4 times 2x minus 5 in parentheses, equaling to 2 times in parentheses 4x minus 10. We're going to look for x, all right? Try to figure out what's going on there. So let's check and see what we've got going here. Let's take a look at this problem here. We've got it ready and mapped out for us, all looking good. I mentioned parentheses. They are important. They're important in this problem because as we're going to solve for x, we've got to work off these parentheses. So the first thing we do is we take the distributive property like crazy here, all right? This is a good old algebra 1, pre-algebra type equation, all right? And we're going to get 8x, how about it, 8x, because that's what 4 times 2 will do for us. Then we're going to take this 4 times a negative 5, or you can say 4 times 5 and we'll subtract it. It's going to give us minus 20. How about that? There, the left side is ready to go. Let's take a look at the right side. On the right side we have 2 times 4 again, which is 8x. And going to go, like say, some of you are wondering, what are you doing, Ernie? We're distributing. And then we're going to take 2 times that minus 10, and that's going to give us minus 20 over there. Now, I'm seeing something, but I'm going to see if we all start to see this, all right? Do you take a look at that? That looks very unusual. And let me tell you why it looks very unusual, because when we start to move this 8x over to the other side, because that's what we want to do is get our x's together. When we take minus 8x here, and we take minus 8x to the left, uh-oh, what has happened? You take a look. Y'all tell me, what's going on here? What's going on here? We have a negative 20, and we have a negative 20. Well, that's okay. It's true. It's true. So we look at that, and we wonder, well, what does that tell us? What does that tell us? Well, negative 20 equals negative 20. If you try to add 20 or remove 1, you're going to be down to 0 equals 0, which is true also. So the thing is, this is a true statement. You say, well, where'd x go? It's gone. It's gone. So what does this tell us? It tells us that this is an identity. We call it an identity. And we saw that identity. I saw it, and I think most of you probably did too, when you had the 8x minus 20 popping up equal to 8x minus 20. Because no matter what number I put in for x, I'm going to get a true statement. If I put a 0 in there, I get negative 20 equals negative 20. If I put a 1 in both of these places, I get negative 12, negative 12. It doesn't matter what number I put in there, fractions, decimals, bigs, large, small, these two sides are going to stay equal. So our solution is all real numbers. An infinite number because you can't count them all. You can't find them all. There are so many solutions to this. So it's a little bit different. By the way, some of you wonder, well, what if we didn't come up with negative 20 and negative 20? What if we come up maybe, let's say, negative 20 and an 8 or something like that? If these numbers were not the same, that means no matter how hard we try, we can't get anything to work. So this kind of situation is either going to be an all, like we see here, or nothing if your x's totally disappear. Okay? That's the story on this one.
For more math help, visit TNLearn.org.